In this segment, I'm going to do as promised, and I'm going to run Valgrind on the Linux cluster on our integer list code and see if we have any memory problems. Okay, so I'm going to take you through SSHing from my local machine to the Linux cluster, show you at least one simple way to do mem check within Valgrind, and look at the report and see what we get and see if we have to fix anything. So let me share my window. Okay, and I'm going to SSH, so SSH linux.cs.u chicago.edu. Let me move that out of the way, and I just put -L in my username. So I did look up my password. I haven't used it in a little while. And I moved over the ilist code. Okay, and so to run Valgrind, I'm going to first have to build the code. So give me 1 second. To build the code, I'll just do gcc ilist.c -o ilist. Oops. I meant to say -o, not -l. Let me fix that really quickly. Okay, so I built the code. Code seemed to work, but there's usually some memory problem. So we're going to run Valgrind -leak check equals yes. That's the simplest way to just do a basic memory check using Valgrind. And we'll look at the report, see what it says, and we pass it the executable followed by any arguments. We're not using any command line arguments. So we just run it like this. And maybe I need to actually say what directory it's in. Okay, and here's my Valgrind report. So my Valgrind report, I have some problems that immediately pop up. And it's a little hard, so don't worry about these. These are just process IDs. And these are addresses of code and code blocks. I wouldn't worry about those. Let's just look what it says. So I seem to have an invalid read in list.clear. So that usually happens when I'm dereferencing a pointer that I've set to null. Okay, there seem to be all sorts of issues in list clear. So I'm gonna have to scrutinize list clear and see what we might have done wrong. What this line here says is that the memory that I'm having issues with in calling free within list clear was originally malloc in list prepend. I'm not as worried about that. So I want to go into that list clear and see what's going on. If we look at the heap summary, which is freeing malloc memory, I have a problem. So this is the line you normally don't want to see. Let's see, this right here. So anytime Valgrind says you definitely lost something, those 24 bytes are suspicious. That looks like I will guess I did not free the list itself. So I freed the elements of the list, but not the list, right? Because it says this was originally created in list.create, and I didn't free them. So I definitely lost memory, and I definitely have some kind of weird free issue here. So it was useful, and Valgrind's going to tell you a lot. They're going to be false positives sometimes, and there are going to be some things that are hard to track down. There are ways to use it such that you can better zero in on what the problem is, but for just a sort of quick check, this is simple and usually gets you what you need. So if we look at the code then, I'm going to go directly to that clear function. And let me first, so we'll look at that clear function, but let me first see where I've called free. Yeah, I never freed the list. Okay, so that's that big problem in the heap report. Okay, so I'm sure that will get rid of that problem, but there's still another problem in clear. Okay, so in clear, if we look at this code, there's a problem with the freeing. So now it's clear. Hopefully you can see it too, now that I'm looking at it. I used my iterator a little too confidently here. So the problem is that the first time through the list, it sets L to list head, checks that it's not equal to null, then it frees it, and then the next time through, it dereferences the next pointer on a freed variable. So that's a bug, and that's not how you want to code that. So let me pause for a second and code it properly, and then we'll see if that gives us a clean Valgrind. Okay, so let me propose this recoding of it that I have right here. So I'm going to say this is a bug. We're going to get rid of this. and I'll fix what's in the Dropbox. We're gonna get rid of that. And now I'm going to need to create 2 pointers. It's probably a better way to do this, but this is what popped into my head. So now I say cur is list.head, cur is not equal to null, cur equals next. Then I get next immediately from cur, then I free cur. So when I go to the next iteration of the list and I say cur equals next, I've already saved next. Okay, that looks good. So this looks like what I meant to do. All right, this was just a horrible bug. All right, so we'll rerun our Valgrind report now that I've fixed 2 things that were obvious and the report seemed to complain about. So I'm going to compile. Looks like I introduced a little bug in the process. I meant to say list clear list. I might have accidentally typed that. Okay, so we're going to run Valgrind, and we want it to say no memory has definitely leaked. This looks good. Okay, so we have error summary, 0 errors. All heap blocks were freed. No leaks are possible. That's the line you're looking at when you're running Valgrind. You're looking for. Okay, so that was a good illustration of a common type of error that Valgrind, if it didn't point you directly to it, at least gave you an indication something was wrong and pointed you in that general direction. Okay, so we'll have a chance later to look at what ways the GDB debugger can help us also, and more detailed and sophisticated uses of Valgrind.